In this episode of our 4-H Flipped Classroom, we are going to be discussing what data looks like by comparing and contrasting. We are going to be checking our WNBA player line plots, and we are going to be learning how to make a mathematical argument. So if you have your math worksheet ready, would you please take a look at your line plot at the bottom where you had to graph Griffith's scores. You can use Mabika's scores as an example of what it was supposed to look like. But when you had to graph Griffith's scores, you had to decide what you wanted the range of the data to be. If you look at my line plot, you'll notice I started with the number 4 and ended with the number 27. I chose those numbers based on the range of data given to me up above. My smallest point value is 4. My highest point value is 27. So I knew I could go from 4 to 27, and the values 0 through 3 really didn't apply to me because I would never plot any data on those numbers. The next step I took was to make a halfway point, and halfway between 4 and 27 was about 15. So I placed that line. That helped me space the numbers 5 through 14 and 16 through 26. If your line plot is nice and organized, well done. If you're looking at it now and it looks a little bit off, please make a note of how we made the halfway point for next time. Now you're ready to start graphing your data. Hopefully you started in the upper left-hand corner with the number 10 and went down on your line plot and made a small X. I would recommend taking a pencil and crossing off the number 10 so you know that you've already marked that data. Next, I would move to 15. Again, make my X on my line plot and cross off 15, and I would do so all the way until the end. A good way to check to make sure that you have marked all of your data would be to count the total number of X's that you have on your line plot and then count the total number of data pieces in the box. You should have ended with 39 each time. Go ahead and pause the video to check your data to make sure that your Griffith scores match up with my Griffith scores that I plotted. Notice how all of my X's are about the same size so that it doesn't change the shape of my data by having some of the X's be larger or smaller than the other ones. Finally, on the back side of your worksheet, you were asked to find the median of Mabika's game. This was an important question to read carefully because many of you may have written down Griffith's median because you were just plotting Griffith's scores, but make sure that you are looking at Mabika's game score. Hopefully you found the median of 12.5. Here's an explanation of how I got there. Mabika played 40 games total. I know that half of 40 is 20. I used the line plot to help me count the first 20 games, and I landed on the number 12. Since 40 is an even number, there won't be a true median or middle, so I found the halfway point between the 20th and the 21st piece of data, which happens to be 12 and 13. And halfway between 12 and 13 would be 12.5. I thought of the number 12 and the number 13 like dollars. And halfway between $12 and $13 is $12.50. So I wrote down 12.5. Let's see if we can do that same line of thinking for Griffith's scores. I found her median was 15. This time I knew that Griffith played 39 games, and since the number 39 is odd, there will be a single middle or median value. I used the line plot to count the first 18 point values. And I did that because I knew there would be a pair for each of those first 18 to cancel out on the other side. That's like the strategy we use when we count X's from the left and the right side until we get to the middle. There'd be a total of 18 pairs. So only the 19th value, or the middle one, wouldn't have a pair, and the 19th value was 15. And finally, you were asked to do a comparison of their points. So how do the number of points Griffith scored in the game she played in the 2003 season compare with the number of points Mabika scored? Write at least 3 statements that compare Mabika's points per game with Griffith's points per game. And you could have put down a lot of different options here. You could have talked about their lowest scoring games to their highest scoring games. You could have talked about their mean, their median, or their mode, or perhaps you figured out their average, which we've been calling mean these last few days. So I'm going to be looking for 3 statements that talk about comparing their data. Now I have a new idea for you. This new idea is called making an argument. Not that kind of argument. This is a mathematical argument. And making an argument in math is what mathematicians call developing reasoning based on evidence. It's not a disagreement or a fight. It's simply stating what you believe to be true and supporting your answer with evidence, exactly like what we do in our ELA classes. Let's take a look at a few examples of how we might make math arguments in the real world. So for instance, before making a big purchase, I'm going to decide if spending that much money is a good choice for maybe me personally or my family, or maybe you've wrestled with that idea if you were making a purchase for yourself. Another time you might use it is if you're at a store and you're deciding what brand to buy. Let's say I'm walking down the aisle and I see 3 different types of peanut butter. Sometimes it makes sense to buy the one that is the cheapest. Sometimes you want a different size or need a different amount. So you'll have to calculate based on a mathematical argument to see which is the smartest purchase. I would also make mathematical arguments when I'm planning meals for cooking. I'd have to decide if I have enough ingredients. I'd have to decide how much I need to make. Do I need to double the recipe if I have a lot of people coming over? Or do I need to cut the recipe in half because there's not as many people eating? I could also make a mathematical argument when creating a schedule. If you have to set an alarm in the morning, you've made a mathematical decision. You had to estimate how much time you would need to get ready in the morning, so you knew what time you would need to get up in the morning. I do the same thing with planning our schedule for the classroom time. I need to make sure that I have enough time to do math and ELA and reading and science and social studies, and so we have to decide what is our best schedule. And finally, you could make a mathematical argument for something as silly as picking a seat. At my house, in our family room, we have a couch and a couple chairs, and I could rationalize that my legs are the longest, so I should be able to lay on the couch rather than sit in the chair. So this could be if you're riding on an airplane, if you're sleeping on the top bunk versus the bottom bunk, and you're talking about weight, but you are always making mathematical arguments, supporting it with evidence. Because remember, math is everywhere. So our final thoughts. In our next math class, I'm going to be asking you to look at the data and making your own mathematical argument. I'm going to ask you, who is the better player? How do you know? Can you back up that evidence? Or can you back up that answer with some evidence? So be thinking about your data, your answers to your question, and possible evidence you could use to support it. And remember, math is everywhere.